Welcome back. On this channel, we break down the technologies that are quietly reshaping work, power, and daily life. We've been told artificial intelligence is a virtual brain living in the cloud, but the truth is, we are quietly wiring our entire planet to run a colossal physical machine that no single nation on Earth can control. Most people think artificial intelligence is virtual. They think it lives in a web browser, a line of code, or a conversational chatbot that can write an email or generate an image in seconds. But behind the text box on your screen lies the largest, most expensive, and most complex physical machine ever constructed by human hands. The AI race is not a software game. It is a physical, material, and deeply contested industrial race. It is a planetary network of supply chains, resource extraction, advanced lithography, high bandwidth memory, gigawatt-scale power grids, and precision manufacturing. In 2026, global capital spending on this infrastructure is projected to reach an unprecedented $700 billion, and as we trace the flow of these resources, a stark reality emerges. No single country controls the system. If any single link in this planetary chain breaks, the global intelligence economy stops. The next superpower will not be decided by who builds the smartest chatbot. It will be decided by who controls the physical machine that runs the future. To understand why this race is so fragile, we have to look at the physical journey of a single state-of-the-art AI accelerator. Its architectural design is drafted in Silicon Valley, California, by engineers using advanced software tools. But the American design firm cannot actually build it. To print the circuit, they must send the design files to Veldhoven in the Netherlands. Here, a single company, ASML, stands as the absolute gatekeeper. Its extreme ultraviolet lithography systems are the only machines on Earth capable of using short wavelength light to etch nanometer-scale transistors onto silicon. Yet, ASML only builds the printer. The actual printing must take place in Hsinchu, Taiwan, where TSMC uses those Dutch machines to manufacture the physical processor. Still, the chip is useless. To process parameters at high speeds, it must be packaged alongside high-bandwidth memory chips manufactured in South Korea by SK Hynix or Samsung. This entire assembly is held together by photoresist, specialty chemicals, and silicon wafers sourced from Japan. Only after this global journey is the finished chip shipped back to a data center in the United States, where it is connected to a power grid to run workloads. This is not a bilateral competition. It is a hyper-integrated, highly vulnerable global machine. The United States is the undisputed brain and financial capital of this global system. In 2025, U.S. private AI investment reached a staggering $285.9 billion. To put that in perspective, California alone accounted for $218 billion, more than 17 times the tracked private AI investment of any other nation. U.S. institutions produced 40 notable AI models in 2024, far ahead of China's 15. But as U.S. tech giants spend hundreds of billions to scale their models, they are hitting a massive physical barrier: electricity. Under a new industrial paradigm known as Watt's Law, progress is no longer limited by the size of transistors, but by the availability of raw power. AI workloads are parallel and run continuously, demanding enormous, uninterrupted power supplies. The International Energy Agency projects global data center electricity consumption to roughly double by 2030, reaching up to 950 terawatt-hours. In the US, decades of grid underinvestment mean technology companies face years of delays just to connect new facilities. This energy bottleneck has triggered a monumental counter-mobilization. Initiatives like the Stargate project, a massive $500 billion infrastructure plan, led by OpenAI, SoftBank, and Oracle, are rushing to secure power sources, including nuclear energy, to prevent the US from losing its technological lead. While America scales brute force compute, China is playing a completely different game. Constrained by strict Western chip export controls, Chinese labs could not rely on ever larger GPU clusters. Instead, they turned to algorithmic efficiency, open source model diffusion, and deep physical adoption. In January 2025, a Chinese lab called DeepSeek shocked Silicon Valley by releasing its open source R1 model. It matched the performance of America's best frontier models while utilizing a fraction of the compute. China has gone all in on open models. Alibaba's Qwen family has built the largest model ecosystem on Hugging Face, with over 100,000 derivatives. But China's unexportable advantage is the physical loop of its manufacturing base. China has installed over 2 million industrial robots, nearly 4.5 times its closest competitor. Under its national strategy, China's industrial base has established over 30,000 smart factories. As open, highly efficient models are deployed across factories, logistics networks, and electric vehicle grids. They generate highly specialized, real-world operational data. This data feeds back into the models, creating a self-reinforcing flywheel. America may have the smartest virtual assistants, but China is building the brain that runs the physical world. The survival of the global AI stack is held by 4 hidden kingmakers who control critical hardware bottlenecks. The first is Taiwan. Taiwan produces 60% of the world's semiconductors and 90% of its most advanced microchips. TSMC alone controls 73% of the pure-play foundry market. This hyper-concentration is Taiwan's silicon shield, the theory that the island is too economically vital for the West to ever let it fall. But a military blockade of Taiwan would cause an estimated 5% drop in global GDP in its first year, freezing the technology supply chain. To mitigate this risk, TechSanct has committed $165 billion in outbound investments to Arizona. Yet, TSMC continues to keep its pioneer R&D and advanced fabrication onshore in Taiwan. The second is the Netherlands. ASML stands as the gatekeeper of advanced computing. Without its EUV systems, advanced chip printing becomes physically impossible. The third is South Korea. Samsung and SK Hynix control the global supply of high-bandwidth memory, the critical hardware component required to feed data to fast GPUs. South Korea has backed this bottleneck with a massive $576 billion semiconductor strategy, paired with the most automated workforce on Earth, boasting a robot density of 1,012 robots per 10,000 workers. And the fourth is Japan. Japanese conglomerates control the foundational specialty materials, photoresists, and diagnostic testing equipment required to run advanced fabs. These 4 regions do not build the consumer applications, but they own the tools that make those applications possible. As the established technological powers fight over silicon, a new axis of AI power is rising in India and the Middle East. India's strength is built on unmatched human scale and digital public infrastructure. India produces 1.5 million engineering graduates annually and leads the world in AI skill penetration. Under its INR 10,300 crore India AI mission, the government is subsidizing GPU compute, while private GPU cloud providers like NASA have raised $650 million in under 2 years. To secure its position, India joined the US-led Pax Silica Tech Alliance in early 2026, securing formal guarantees from Washington against sudden technology cutoffs. But compute requires physical space and energy, and that is where the Gulf enters the race. with Western grids facing up to 5-year connection delays. The United Arab Emirates and Saudi Arabia are leveraging their structural energy surplus, nuclear reactors, and solar buildouts to become compute safe haven hubs, backed by the UAE's $100 billion MGX fund and Saudi Arabia's $100 billion Project Transcendence. The Gulf is purchasing massive GPU clusters, including a massive 1 gigawatt computing cluster in Abu Dhabi. In the 20th century, these nations shaped the global economy through oil. In the 21st, they plan to do it through megawatts of intelligence. We have built a global civilization that runs on intelligence, and we have concentrated its production into a fragile, hyper-interdependent stack. The United States has the brains and the capital. China has the manufacturing scale and the deployment flywheel. Taiwan has the advanced fabrication. The Netherlands has the lithography. South Korea has the memory. Japan has the materials. India has the talent. And the Middle East has the energy and capital. No single nation controls this entire machine. The winner of the AI race will not be the country that builds the single smartest model. The winner will be the nation or the alliance of nations that can successfully organize, power, and secure the full industrial system. Because in the 21st century, national security is inseparable from compute sovereignty, and the future belongs to those who build it sovereign. If this video helped you see the AI race differently, please like, share, and subscribe. It really helps the channel grow. And if you want to see what this future could feel like inside your own daily routine, watch the next video. What if AI agents ran your day? That one explores what happens when AI stops just answering questions and starts acting on your behalf.